Now let's review the empirical rule from chapter 3. So remember, for the empirical rule, as long as we have a symmetric bell-shaped distribution, which the normal distribution is, then our standard deviation has the characteristics that within one standard deviation of our mean, either above or below the mean, we have 68% of our data lying there. We have about 95% of our data within 2 standard deviations of the mean, and 99.7% of our data within 3 standard deviations of the mean. So you may remember this as the 68, 95, 99.7% rule. In pictures, remember, if this is your normal distribution, then you have 34% of your data within the mean and 1 standard deviation on either side. And combining those, we get the 68%. Similarly, you've got 95% within 2 standard deviations, and then remember, we can then take away that 34%, so divide it in 2, take away the 34% to get 13.5% within 1 and 2 standard deviations, either above or below the mean. And similarly, do something similar to get the 2.35% within the 2 and 3 standard deviations. And combining those, you get the 99.7%, all within 3 standard deviations of the mean. So this should be a review for you. So, as an example, in a survey conducted by the National Center for Health Statistics, the sample mean height of women in the United States ages 20 to 29 was 64.3 inches, with a sample standard deviation of 2.62 inches. So if we want to estimate the percent of women whose heights are between 59.06 inches and 64.03 inches, so we can assume this is normally distributed, so height of women is typically going to be normally distributed. So we can use the empirical rule. So sketching out our normal curve, remember basically the whole idea is we want to figure out how many of our data values lie at each location. So the percentage of our data values lie in there. So we know our mean's in the middle. So if this is our random variable x for the mean height of women, we know the mean of this distribution is 64.3, so that goes in the middle. And then we know the standard deviation is 2.62 inches. So if we add or subtract 2.62, then we go out one distribution. So if we do that, so 64.3 plus 2.62, we get 66.92 for 1 standard deviation above. Similarly, subtracting it from 64.3, we get 61.68 for the first one below. And using a similar approach, we can find 2 and 3 standard deviations above or below the mean. Now, because we have 99.7% of our data within 3 standard deviations of our mean, there's only 0.3% of our data that's not accounted for, so we really don't need to go out further than 3 standard deviations from the mean normally. So if we keep on working our way out, so 61.68 minus another 2.62, we get 59.06. And go up another one, 66.92 plus the 2.62, we get our 69.54. And we could go on out to our 3rd standard deviation. In this case, we want to estimate the percent of women between 59.06 and 64.3 inches. Well, we've already accounted for those. So we've got our 59.06, we've got our 64.3. So if we look at that region and shade that region in, we're at 2 standard deviations below the mean and our mean. So if we go back and look at our graph, so we are here. So we're between here and here. So we're 2 standard deviations and our mean. So we're in this region. So if we want to find that area, well, we know we have 13, and so we have a couple different ways. You can do the 13.5% plus the 34% to get our 47.5%. So you can do that, or you can just take the 95% and divide that by, that's within 2 standard deviations, and divide it by 2 since we're only concerned with that lower half. So either way, if you do it that way, so the 34% plus the 13.5% would give you your 47.5%. Or just remember that you have 95% of your data within 2 standard deviations of the mean on both sides, and we only have one side, so we're dividing that by 2, and you also get your 47.5%.